This episode is sponsored by Linode. Do you need a Linux server for your latest creation? Then check them out. They provide native SSD storage, 200 gigabit per second network connections, Intel E5 processors, and top-of-the-line hardware to run your servers on. It deploys Linux in seconds from a Linode cloud, and you can choose your Linux distribution and node location right from the manager. They have locations in Asia, North America, and Europe, and a sweet set of tools to make it easy to manage it. If the web interface isn't your thing, they also have an API and a command line. They also provide two-factor authentication, IPv6, DNS manager, plumbing, scaling, and everything else you would want. So get the most out of your Linux node by checking them out at linode.com or devchat.tv/linode. Hello and welcome to React Native Radio, episode 92. I'm your host, Nader Dabbit. Today on our panel we have Spencer Carley.
Hey everyone.
And our special guest today is Michel Weststrate. Welcome to the show, or welcome back to the show, Michel.
Hi there.
Our topic for today is going to be Immer and MobX State Tree. Both of these libraries have been written by Michel.
And what do I do in my day-to-day life is that I'm a tech lead and open source evangelist at MobX, which is an enterprise software vendor. And what we do is we basically sell technology to really quickly build applications. And then the kind of business-to-consumer applications which is used are developed by insurance companies, banks, those kind of software. That's what we basically assist in. And what I try to do, like on a daily basis, is connect open source to the enterprise world and the other way around. So bringing open source solutions and processes into a big company like Mendix, and also the other way around, open sourcing stuff which is like technological, really interesting, but not per se our IP. So, for example, MobX was the first library I did that with, which we developed initially internally, and then we figured this is useful for a lot of other people, so let's open source it.
So you guys were using Mendix. You were using MobX at Mendix. You kind of developed it internally, and then you open sourced it from there?
Yes, definitely. Yeah.
Okay, cool. So that's pretty interesting. So I guess Mendix is very open to you working on open source kind of as part of your day-to-day. So you don't really have to worry about only doing this in your off time. You get to actually work on it at work.
Exactly. So I'm allowed to spend like 50% of my time on open source related stuff, which is not just maintenance, but also giving talks, workshops, those kind of things.
Oh, cool.
So yeah, I'm in a quite privileged position to say so. Yeah.
Very nice and very cool of Mendix to kind of have that type of culture. But you're also, creating such powerful stuff. It wouldn't be very smart of them not to let you do that actually anyway. So, I mean, it's pretty interesting.
That's also kind of true. Yeah. but you also have to see it in a bigger picture. Like companies like Mendix, we purely sell technology. So we don't bill hours to our clients or something. We just sell them our technology, and that's what they work with. So we want to be ahead of our game, both today and tomorrow. So we always try to see how we can adapt the latest technologies in our stack to make our customers go faster than their competitors, basically.
So that's an interesting business model for a company that, like, I would at first have assumed was a consultancy, but I don't even know if this falls into consultancy if you're actually selling technology and not hours. What would kind of a contract look like with Mendix? Just out of curiosity, for something like what you're talking about, would they be like talking to you about what's available, and then you have like some solution, and you just basically like hand them over like a certain code base for X amount of dollars, and then maybe help them kind of implement it, or how does that look? Just
Well, so we, in essence, we don't sell directly to our customers. So we have our implementation partners, which can be companies like Capgemini, SAP, etc. And so those partners, they are specialized in certain fields. So some are in the medical industry, some are in the insurance industry. And what they do, they use our technology to build applications for their customers. And the business model is like they build the hours to build that application, and they run it on our infrastructure, and that's what we get paid for. So basically, we give our technology also away for free. But the partners, they have their customers hosted on our infrastructure, and that's where you get the money from. So it's really a software platform as a service is what they call it. And so it's pay per use, which is also very interesting for customers, and it's very scalable for us because, well, the more our partners sell, the more they build with our technology, the more customers we have in the end. I think consultancy from consultants is in that sense a nice summary. It's basically we enable other people to develop software in a very efficient way.
Okay, interesting. I guess let's go ahead and jump into some of the topics now. Can you go into just a brief overview of what Immer is, when it was released, and what problems it solves, I guess?
Okay, so Immer is a very tiny library, and it helps you to work with immutable data. And that is not something new. There are dozens of libraries doing that. But there's very few unique things about Immer. And that is that you just work with normal JavaScript data structures. So there's no new API to learn, no new kind of data structures. You just use normal JavaScript objects. But on top of that, you also use just the normal JavaScript APIs to work with these objects. So if you want to produce your next immutable state, you have learned probably to take your current state, you spread it out into a new state object, and you mix in some new facts, which you also want to store in that state. But with Immer, you do that in a totally different way. You just take your current state, you make some modifications to it, like doing assignments or using array operations like push or whatever you feel convenient. You can use other libraries for that if you want. And then it seems like you're mutating your current state. But in fact, it is proxying all the modifications you make into some kind of shadow copy. And the result of that is that although you're seemingly mutating your objects, you actually aren't. And both your old state and your new state, they are completely frozen. They use structural sharing to share facts that didn't change. But it's just a way more convenient way to operate with immutable data structures without giving up any of the semantics.
So one of the things that I don't like about immutable.js is the fact that there is kind of like a new API to learn. So I really like the idea of being able to work with just regular JavaScript APIs. And I think that's definitely a compelling, thing. Is this something that you would use maybe along with like Redux in a React or React Native application? Or if not, like where would this be used within React or React Native app?
Yeah, so in essence, it's a super generic library just for immutable data. And wherever that is applied, you can apply Immer. It is very useful, though, especially with Redux, because it makes the reducers way smaller and way more concise. And the deeper your updates go, or the more complex your updates are, the more that's gonna go to pay off. So Redux reducers are a really good place to apply them. But also set state of React itself is a really nice way because it follows the same paradigm where you have an object and then you express some mutation of that object, and that's your next state. So what you pass to set state. And so you can also use Immer very well to make a producer, that's how we call it in Immer, out of your set state calls.
Yeah, I found this, it's very interesting. So I've never heard of Immer before. I typically approach development of just kind of keep my head in the sand until people are talking about something so loud I can't ignore it anymore. So I'm happy to like actually look at Immer because there's two problems I've seen in teams I've worked with in the past. And first, when using immutable JS, especially like if I'm training someone to use React Native at the same time, immutable JS just brings in this. It's a whole new API in Natter. You mentioned this as well. It's a different API. It's a different way of thinking about things. So that makes it difficult, but you do have the benefit of data is always going to be immutable. And then on the other hand, and this is something I struggle with anytime I'm working in a relatively complex application of updating nested data within Redux or within just a component state. I'm loving how within Immer, I don't know. So like something I'm constantly doing is, you're spreading the existing state and then you have to spread the, using object spread, any nested data. And you just have to keep doing that until you can actually get down to the data that you're trying to modify by using Immer. It's very interesting the way that you don't have to go down all these levels, constantly trying to basically rebuild that state, and then getting to actually just modify the data you want to. But what the question I've got is, when using this approach, like, is all of that happening behind the scenes? How does this actually work? Because as a developer, as a consumer of this API, like it's so simple, but how is it actually implemented behind the scenes to make it so simple for me as the developer just writing this code?
The easiest way to explain this is probably to start about how I started on Immer. So last year already, maybe even longer way ago, we decided that in some future MobX would be based on proxies. We postponed that, I think, for almost 1.5 years now, because now finally browser support is good enough. And so in December, last December, I figured I wanted to have more hands-on experience with proxies. And so I figured this kind of exercise for myself to spend one day on writing copy on write collections with proxies. So in languages like Java, you have these built-in collections, and as soon as you modify something in those collections, they first create a copy of themselves, and then they give you the copy back, which makes working with immutable data really intuitive and straightforward. So I figured maybe I can do the same with proxies, that as soon as you try to modify an object, then I immediately create a copy of it, and then I apply the modification. I intercept it, and I apply it to the copy. And so I built that in kind of a day. And only after the day, I figured this was actually useful for something, namely for reducers. But it just started as an exercise, just a practice exercise. And so what Immer does is, as soon as you are reading to your tree, so you're accessing any attribute of an object, as soon as you do that, as soon as you read a part of the tree, it creates a proxy around that object which the property is pointing to. So then you get a proxy of the same object as that was there originally in the tree, and you won't notice it because it's literally the same object, but in fact it's a proxy. And if you then start to modify that object, that proxy, it will just apply the modification. And although it seems like it's applied to the original, it isn't applied to the original. The modification is applied to the proxy. So the original data is untouched. And you can actually verify that very easily in Immer by just passing some frozen data to Immer. And then you will see that you can still modify it. And so in Immer, you write one function that modifies what we call the draft state. And in the end, when you're done with it, it just visits all the proxies you've created by adding something in the tree. And it freezes those objects so that those become immutable. And then you have your next state. And so basically it creates lazily proxies for all the parts of the tree you visit. And the nice thing actually is I was in the end also able to write an implementation that works without proxies, which is still something needed for a library which is generally applicable. And so the non-proxy version is slower because we cannot detect property additions as easily, but it works semantically completely the same. And so I released that, I think, in the second week of January or something. And then it went really quick because in a few weeks it covered thousands of stars on GitHub. So it's now at 3,500, I think. But that's roughly how Immer works. It's kind of hard to explain just in words and without pictures. But the essence is when you walk over the tree, every part you visit is being proxied, and the mutations are applied to the proxy instead of to the original.
Very, very interesting. I love how it was just like an experimentation you wanted to do, and just trying to learn, and then this turned into this library that seems so useful. Now, is there any instance where you would think Immer wouldn't be a good fit? Like, are there any like anti-use cases for this library?
Yes, actually there is. So where Immer doesn't fit is if you combine immutability with a non-JavaScript, non-plain JavaScript structures. There's hardly anybody doing that. But if you store your immutable state in class-like structures, then Immer won't work out for you out of the box because it doesn't know how to clone these classes. But I think that's a pretty rare case, and I had so far nobody complaining about that. So I think if people use immutable data trees, then they also use typically only plain objects and plain arrays.
So something you mentioned earlier that was pretty interesting to me and that I see kind of listed as one of the benefits is the deep updates and kind of how that this makes it easier to do deep updates. And mainly for me, that means if I'm using Redux and I have a deeply nested object or array that I need to manipulate, right now you basically have to return layers of state until you get down to that item, and then you have to do the manipulation there. And basically with the example that I'm seeing on the website, on Immer, or on the GitHub repo, it basically kind of abstracts most of that away. But I'm seeing this, so is produce kind of like the main method or the main function, or I guess is produce actually the entire Immer library? Is that kind of what you use for pretty much everything?
Yes, it's actually used for pretty much everything. It has two forms. One is to directly call it, and one is to use a query invocation. And the query invocation means that you take a function and then bind it to a producer function so that you can pass the new states later on, and it has a recipe basically of the operation it wants to perform. But produce is the entire API of Immer indeed.
Okay, cool. And then it looks like produce has two arguments that I'm looking at here, like state and draft. You may have already mentioned this, but can you kind of maybe just give a description of what that is? Because I know people listening in their car or if they're running, they might not get this, but if someone is listening and they kind of want to go back and reference some of this stuff, I'm kind of curious if you can give us a general idea of what the state and what draft is. I'm guessing state is kind of the existing state or something like that.
Yes, exactly. So produce is a function which takes two arguments and returns one thing. And so the first argument you pass it is the current state. The thing it will return in the end is the next state. And the second argument you pass it is a function, which itself takes one argument. And that one argument is what you call the draft state. But actually, it contains exactly the same data as the base state you passed in. So the first the data passed to your callback, so to speak, or to your producer function, is always the base state you passed in to produce. But it's not literally the same object. The only difference is that the draft state is the proxied one. So on the draft state is the proxy I told you about earlier, and that you can modify in any way you find suitable. And the only thing is that when that function ends, so that function you provide the second argument, when that function ends, Immer will produce the next state based on this draft state. So the draft state is in the end returned as the next state.
Okay, that makes more sense after looking at this. That explains it fairly well. I actually probably need to use it to understand it fully and kind of, get a good idea. So I think next time I use Redux, I may drop this in and give it a spin. I do have another question, though. I know that there's a lot of people that are using GraphQL now, and they're using Apollo and these other libraries to kind of start managing some state. I know if you're dealing exclusively with GraphQL APIs, it makes it much easier to get rid of things like Redux, maybe, or if that's kind of what you want. But I'm kind of wondering, is there any use case for Immer, or really this is more like a general immutability question? Does immutability make sense when you're working with GraphQL, or does it kind of take away the need for immutable data?
I think you could apply it in small scale. Like if you describe a mutation, then you could do that by grabbing your current state, modifying it using Immer, and then feeding that to the mutation. I think that would be the main application, but whether that's beneficial is probably depending on how large the mutation is you're describing. Like if it contains really complex data, then it might make sense. And otherwise, it's probably not that much of an added value.
So let's go ahead and move on. So before we do that, actually, before we move on to MobX State Tree, what are some resources that people can use to kind of get a quick idea of what Immer is and how to go about implementing it? Is it the GitHub repo the best place to go?
The GitHub repo is perfectly fine. There's also a video tutorial of like 7 minutes, I think, about it on egghead.io. It's free, so you can watch it to get a really quick impression on how to use Immer and how to apply it to Redux, for example. And I think you will find out quickly what makes Immer so unique. Because one of the major feature points, we didn't discuss even yet, is that it's very suitable for strong typing. So there are dozens of libraries already that are supposed to make it easier to work with immutable data. But lots of them, they have APIs like deep update in, and then you give some bunch of strings to specify where you want to update something. And then you're basically writing queries against your own client-side state. And it's really hard to type check within the existing type systems we have. The same holds effect for immutable.js as well, which is type checkable, but only partially. And that is completely solved with this approach, because these are just normal JavaScript APIs. So type systems like TypeScript and Flow are perfectly capable of understanding what you are doing and what you're supposed to be modifying and whatnot.
Very nice. I definitely use Flow, so this is going to be a good addition for me. Can you give us a quick overview of what MobX State Tree is versus MobX? I know a lot of our listeners kind of already know what MobX is, but even just a general, elevator pitch of MobX State Tree, and then after that, maybe like how it relates to MobX.
Yes, so MobX State Tree is kind of a model library, a library where you describe the shape of your data tree in terms of models. So you can compare it a little bit with prop types in React, which describe the shape of the props you're passing in, but then way more extensive and applied to your whole client-side state model. And so the gap it is filling is so MobX State Tree uses MobX under the hood. And if you're fine with MobX, then you're perfectly fine without MobX State Tree. But a lot of people were like, MobX in itself is too free. So MobX helps you to propagate updates through your application, but it doesn't tell you anything about how you should be structuring your state. Because it doesn't have any opinion on it, and because that allows MobX to be applied in many different paradigms, many different architectures, and it allows it to be applied very easily into existing applications. But sometimes for people, we notice it's kind of overwhelming. That it doesn't answer questions like, should I be using classes or not? Should I be using singletons or not? Should I collocate my actions with my data or not? And MobX doesn't care about, but MobX State Tree does. So it's an opinionated, possible implementation of a client-side state architecture based on MobX. So in MobX State Tree, you describe the model of your entire state tree. So you can say, like, I have a to-do store which consists of to-dos, and to-dos are an array of the to-do model, and the to-do model has these and these properties, etc. And by doing that, it can give you a lot of nice features out of the box. Because you define the model, we know how to serialize the model into plain JSON. We know how to generate JSON packages when you modify it. So you can get JSON packages out of the box. So you can do out of the box things like time traveling, but also proper undo redo. And with proper, I mean the kind of undo redo which is based on patches and not on snapshots. It offers things like middleware out of the box. And we can offer all those kind of things because we know about your state shape. So we can offer a lot of solutions out of the box. And so some very interesting things you can express very neatly with MobX State Tree is how references work. So you can say, I have this view store and it has a current selection, and the current selection is a to-do, but it's not a to-do itself, it's just a reference of a to-do. And if you describe it in your state model, then we can do all the normalization behind the scenes for you. So instead of you needing to store an identifier of the to-do and then looking up the to-do whenever you need it, whenever you need to read something from it, we actually do that behind the scenes for you. So you just read from that current selection and you get the real to-do back. And behind the scenes, we know based on your model description, this is a place where we store just identifier and not the thing itself. And so it's kind of a, maybe you can even call it a lightweight ORM for client-side state.
Yeah, so one of the main things I noticed about MobX State Tree when I started using it, and the things that I appreciated about it, was the fact that it did have its own opinions. It was opinionated. It had typing like out of the box, and then the fact that there are helpers to kind of help do some of the mutations that Redux or even MobX just really made it a little more difficult for nested data again, kind of like we talked about with Immer. There were helpers like destroy, I think it was, which basically allows you to kind of delete an item from an array, and it made it pretty nice to work with. But I think I interrupted Spencer. What were you going to say, Spencer?
Oh, I was just going to ask, kind of when you were building out this API, was it like inspired by any other APIs? Because I've never used MobX State Tree, but just looking through it, like it reminds me a lot, especially the way you define the models and everything, of something like Mongoose for MongoDB. And just, I don't know, how did you develop this API? Was it inspired by something, or was it just, purely based off of the needs that you had within MobX?
No, what it was based on is our own ORM layer we have in Mendix. So in the past, I got a lot of discussions like, I cannot do this or that in MobX. And then I was like, yes, you can, because we do the same at Mendix. And then the obvious question, the follow-up question is, okay, so how did you do that? But then I couldn't share that because that part of our code base is unique to our product. And so it is IP. So I figured I should just write a package capturing those patterns and make them reusable for others. And so that is kind of how the MobX State Tree model originated. So it's basically based a rip-off of some parts of an internal product.
Gotcha. Very, very interesting.
So can MobX State Tree be used with anything other than React, or is it mainly kind of just used with React?
No, you can use it basically everywhere, and especially everywhere where you can use MobX bindings. So if you use, for example, Preact or Angular, they both have very good MobX bindings. And so that means that if you write your state model in MobX State Tree, and you use the MobX bindings in your components, that means that components will automatically respond to changes in your MobX State Tree.
So if you use MobX State Tree, you have a dependency on MobX, right? So you basically have to install both MobX and MobX State Tree.
Yes, that's correct.
Cool. Yeah, that's what I remembered. And there are things that kind of remind me. Of course, there's a lot of stuff that kind of reminds me of MobX, like as far as using I think it's Observer. You still have to use Observer, right?
Mm-hmm.
Yeah, so if you've used MobX, it's fairly easy to like implement MobX State Tree. A lot of this stuff is similar. It just kind of abstracts away some of the things that you may not have known the best practices for, I guess. One of the things you mentioned earlier, this goes back to MobX, the things that people ask you, like, what are the best practices? And one of those, you mentioned a couple that I've actually had discussions with people that I remember directly talking about. One of them I think you mentioned was the singleton pattern. Is that kind of the right way to go with MobX in general, or is it better to use I think it's like inject at a provider, or does it really matter? This is more like MobX versus MobX State Tree.
Yeah, I think it really depends on your project team. So from a principal standpoint, I'm kind of inclined to say don't use a singleton pattern ever. Because when you use singletons, it will lock instances to your module scope. And that means that you cannot, for example, safely run unit tests in parallel. But to be honest, in practice, when your project is not too complex, and if you have a good mechanism to recreate your singleton or to reset it to its base state, then singletons can work out fine for smaller projects or smaller teams. Especially because it's like really easy to implement. So because you're using MobX, if you just import singleton store and you read from it in your observer component, that observer component will start tracking that singleton store, regardless of the fact that you didn't pass it in through context or props. Because that doesn't matter for MobX, that singleton store pattern is actually more viable when using MobX than with any other state management solution.
Right.
But from a principle.
Yeah, that's kind of what I've heard too about. That's kind of the consensus we've come to based on our and other people's, their examples and their just discussions more around the testing, the unit testing.
Yes, I think that is the biggest downside, like how you're going to test and reset stuff when using singletons.
So we are kind of getting close to being there on time. Is there anything that you want to discuss or anything important that we haven't really gone over yet? Or is there any question? Are there any questions from either of you that you want to just run over before we wrap it up?
All good from my end.
Okay, cool. Well, I think we can go ahead and get to the picks then. Spencer, do you have any picks?
So I actually don't, suffering from a serious case of the Mondays this week. But just in general, I'm going to give a shout out to the React Native training blog, because just anything Natter's been publishing lately, especially if you're interested in AWS AppSync or any of the AWS products, because I know a lot of people have been asking me how to use that. And he's just had so many good resources that I can just point people to. So definitely anything on React Native training blog, or if you're looking for anything AWS AppSync related, like I know I am, I'm slowly starting to play with it. Natter's got a bunch of awesome content out there about it.
Thank you. I appreciate that. Yeah. I'm doing a lot of stuff, like Spencer said, around AppSync, which is the GraphQL database. And I would call it a database as a service, even though they don't really call it that. It's kind of what that's the easiest way to kind of relate to people kind of what it is. A lot of development going on right now with it. So we're adding features and stuff. So check it out if you're interested in GraphQL and you don't want to set up the database yourself. So my pick is, I have, I guess, 3 picks, but 2 of them are conferences. So the first pick I have that's not a conference is the Artsy open source blog. There was a post by Orta Therox, who was on our show about 2 months ago, and it's called React Native 2 Years Later. And he kind of gives a really good in-depth discussion or just overview of his and his company's just experience with React Native, the good and the bad. And it was really nice and well written, and it was very informative about kind of the decisions that were made at a really enterprise level, and a really level of like from people that have had a lot of experience with React Native. So it's really good information. My other 2 picks are Chain React, which is the React Native conference in Portland. It's coming up in July. Tickets are already on sale. It's going to be really cool. Last year, it was my favorite conference, but not because it was a React Native conference, just because Portland was awesome and it was put on really well by Infinite Red. So that, and then there's also the React Native EU conference, which was also going to be later on this year. I think it's in September, and I'm not sure if the tickets are on sale, but I know they've announced the date for it. So if you're interested in going to a React Native conference and you're in the United States, or you're like somewhere in or around Europe, you have 2 good options there. So definitely check those out if you haven't already done that, or if you haven't already been to one. Even if you have, go back. It's fun. So Michel, do you have any picks today?
Yeah, I compiled a list of 4. Am I allowed to have 4?
Oh yeah, totally. You can have as many as you want.
Cool. So the first one is, I think, Flutter. It's like a React Native competitor from Google. And I think they announced their beta like last week or something. And I think it's very interesting to follow because probably they might be doing some things better than React Native, and then React Native will catch up again, etc. So that might just be interesting to follow from a React Native perspective and to see what that means for the future. The second one is an DC39 standard, which I was playing with last week. And after that, I was like, okay, this proposal is way underestimated. And the one is a proposal about async iterators. And it sounds like really scary. And it's basically a combination of async await and generators.
Yeah, that's exactly what came to my mind when you said that. But go on, I'm sorry.
Exactly. So now it sounds even more scary. But what it basically allows you to build is like a stream of promises. And so it's more than async await by itself. It's very suitable for processing long-running processes and just pulling off some new values from it, but getting those values delivered asynchronously. And so it's still pretty fake, but it has some interesting cross-pollination between reactive streams. So you can kind of express similar things than reactive streams, but then like more core to the language. So with built-in language syntax support, so you have. So I've seen many people starting with async away, making mistakes with, for example, for loops or maps that they map over an async function and that didn't do what they expected it to do. And with async iterators, you have for await syntax, where you can actually express what you always wanted to express while mapping over promises or something. So I'm really aware that this is still sounds very vague and complex, but I think some powerful stuff can come out of it in the future. I might want to dive a little bit in some of the presentations that are there online. Third pick is the React Dev Summit, which is next week, and it's an online conference, which you can either pay for or not. Obviously, paying for it has some benefits, but you can attend all of the sessions for free as well. And I will giving an extensive talk about MobX State Tree there next week, Friday. And the last but not the least, on the 13th of April in Amsterdam, amazing city, there's the React Amsterdam conference, which has a dedicated React Native track. It seems to become very big, like 1,200 developers. So you might want to chime in there as well.
Awesome. Yeah, to tack on a couple of those things. If you're interested in Flutter, I have a blog post called Flutter for JavaScript developers. And then I think there's now some documentation on the Flutter website that's called Flutter for React Native developers. So if you're looking to get into Flutter, those two resources should be good if you're already familiar with JavaScript. Also, React Dev Summit. I think if this episode comes out, when I think it's going to come out, you'll still have about a week or maybe it'll be during the week of when the Dev Summit comes out. I'm going to be giving a talk on GraphQL with AppSync at the Dev Summit, and it is free. It's really cool that it's free. You're basically getting, really good content. I mean, people like Ken Wheeler, Brent Vatney, Michelle is going to be there. Some of the top speakers in the world are going to be there, and to go for free is pretty cool. So definitely check that out. And if you can, if you would like to buy tickets, it definitely helps out the future of these summits. Hopefully they'll do more of them in the future. But if not, it is possible to attend for free just to watch live, but you can't really, I think, download the videos and stuff. There's a few things that you get if you actually pay for the registration, which is still a fraction of the cost of like a regular conference. Okay, cool. Well, I think we're done. We're going to go ahead and wrap it up. So thank you, Michelle, for coming back on, for taking time out of your schedule to join us. I know everyone listening learned a lot today.
No problem. And see you somewhere.
Yeah, I'll see you in Amsterdam, actually. I'll be there, React Amsterdam. So,
cool.
Looking forward to it. Let's get a drink.
Definitely.
Well, that wraps up episode 92 of React Native Radio. Thank you for listening, and we'll see everyone next week.